Fleming's right-hand and left-hand rules for electric generators and electric motors. This is something that stuck out to me because when I looked at things like, stars, I noticed matter was moving all about in it, from place to place, and that the sunspots, they moved and they grew and they collapsed upon themselves. And a lot of the sunspots had inwards moving material as well, solar prominences, which arched up over the star and, transferred matter in giant arching rivers that would dwarf the Earth. I came to the conclusion that there's definitely something to do with all three concepts, such as the motion or the force-induced electric current and the magnetic field. And we can determine which way these things are going just by looking at those prominences. And we can tell how the material will be projected, being determined by where the magnetic field is and where the electric current is. So there's two main concepts. These are actually one and the same, but they're different. They're different phenomena. They use them in industry. Obviously a generator is not a motor is not a generator. They're used for different purposes. But an electric motor takes electric current, maybe 120 VAC or 240, 480, I think 600. I don't know for 600 volt motors. Probably are, I'm not too sure. I wouldn't doubt it. But I'm not into industry a lot. But we have a magnetic field going in a certain direction, and we have that electric current going in a certain direction, and that'll cause there to be forced motion in the material, which means the motor will spin in a right-hand angle, or 90-degree angle to the magnetic field and the electric current. So that right-hand rule, you just hold your hand up. The magnetic field is always your index finger, the electric current, and you have the induced motion. Now, electric generators, I guess, are opposite. You obviously have, your motion, which is a current-carrying conductor, such as copper. For industry purposes, it's usually always copper. And then you have plasma, which is inside of stars, But you're not going to see electric generators mentioned inside of any material concerning stars because, they're nuclear. Who cares about how electrical current is produced? But anyways, we'll see that that's just simply their myopic nature of astronomers. They just ignore what they're not taught in school. But you have a magnetic field, and you have the force, so the motion of the ionized matter. So if the ionized matter, which are particles, negative or positive particles, or even, plasma that's already recombined, but it still has a little ionization, then if it's moving in this direction, if it's moving up, and it cuts a magnetic field, an electric current will be produced perpendicular, that's the word I was looking for, perpendicular to both the magnetic field and the direction of motion, which is really cool because once you have the electric current produced in this fashion, obviously you have ionized matter moving inside of the star, and it cuts magnetic fields, which are very, very predominant all over the star. You can determine which way the electric current will go. And then once you have that electric current, you can then plug it into this one, say, okay, we know which direction the electric current is going, and we have the magnetic field orientation. Boom, you go all the way back to the magnetic field. You can tell, the forced material. You can tell where the material is being forced. So given what your variables are, I mean, you can have electric current and know those two, and you can find out which way the material will be forced. Or you could have the plasma in motion. You can watch it moving from place to place. And then if you have a magnetic field present, you just put those two in, and you can tell which direction the electric current will be going. That's basically it in a nutshell. I don't mean to be any more confusing than that. But the reason why I wanted to say this is because you can apply these simple concepts to plasma, which is in the stars, and young stars like the sun, or maybe red dwarfs, which have, crazy magnetic fields as well. And you can also apply them to, things such as pulsars, which have very, very, very strong magnetic fields. And you can also apply them, now I wrote this out a while ago, but you can even apply these simple concepts to, you could probably apply them to the salt water in the oceans. If you have, a current carrying conductor moving, such as salt water, across the magnetic field, being the Earth's global magnetic field, you can determine which way the electric current is flowing. But I think it would be more interesting to do it this way, but at the same time, there are a lot of different ways you can apply these concepts. But think about stars in their interiors. I mean, even Jupiter, the way the atmosphere rotates. Really think about that. Really think about which way the ionized matter is moving and how it cuts those magnetic fields, because that will determine which direction the electric current is going. And obviously that would play into building up a capacitor for future release of energy. For instance, if you have two plates, an anode and a cathode, and you have charge building up, say negative charge down here and positive charge up here, okay? And then you have, the equalization event, which is, lightning, and that acts as a giant capacitor and releases an enormous amount of light and heat. Imagine if we could use that very same idea on the surface of the sun, where all the granules are. I don't know if I can draw granules very well right now. But you have these granules that convect, obviously. We went over that in our earlier talk. But somehow you could probably charge up areas where a lot of charge can be built up, and then maybe the charge gets too great for this area, and say like down here, and you have like a large filament stretching from place to place, and then all of a sudden you have like maybe some type of event where it equalizes and blasts out energy, Now I haven't really worked through that concept. Obviously, it's not very well explained, but I will work on it eventually. I just wanted to get this across to people because it's important to know how this stuff actually works. Electric Universe, they want to tell you that, stars are powered externally, which means they're somehow connected with giant rivers of plasma to each other, which, is a bit strange, because the forced material is traveling away from the star. The electromagnetically forced material is traveling away from the star. And given the magnetic field is traveling, at 90-degree angles to that, which means magnetic field will stay put, and then you have the electric current traveling, 90 degrees to whichever direction that ionized material is moving. So, you have your forced stuff outwards from the star, which means that both the magnetic field and the electric current stay put flat on the star. So, say you take a square portion of the surface. Yeah, the forced material is traveling, through the z-axis away from you, but that also means that the electric current is going this way and the magnetic field is going this way across the surface of the star, meaning there's nothing connecting stars together. If there's any electric current, it's on the surface, and as well as the magnetic field is on the surface, because the electromagnetic force material is coming out of the star in all directions. So, I don't know, that's just another idea that I wanted to point out. If, the stars are externally powered, then you have to have material entering it in just as the same amount, if not more, in some cases, than there is material exiting it. But all we know is that the material is exiting the star in large amounts, and there's no matter going into. So to have the stars externally powered, I just think there's too much to explain. I mean, this is pretty solid stuff because we use that in industry, but to say, stars are externally powered and then, ignore all of this, I don't know what to say about that. All right, today is July 19th, 2015.